Now we are going to study question from October 2015 exam, question 1. Okay, everyone give the heading October 2015 exam, question 1. Okay, everyone give the heading October 2015 exam, question 1. This is the question we are going to study. Now I am going to read the question. Please everyone try to read the question with me carefully. What they are saying in the question: a light cord passing over a light smooth pulley. Okay, try to see the point here. A light cord passing over a light smooth pulley has a masses of what, guys? 2 kg and 4 kg respectively attached to its end. Okay, a light cord passing over a light smooth pulley. Okay guys, try to see the scenario. We have a light cord passing over a light smooth pulley. So whenever they said smooth pulley, guys, underline that word smooth pulley. So whenever they say smooth pulley, what does it mean, guys? Whenever they say smooth pulley, what does it mean? Whenever they say smooth pulley, okay, tension on both sides will be same. Okay, try to see the scenario. A light cord smooth pulley has a masses 2 kg and 4 kg respectively attached at its end. Pulley has a diameter 300 mm. We don't need that dia. The 4 kg mass is held 3 meter above the ground level. Okay, so try to see the scenario. Here I am going to draw the drawing. This is what, guys, our pulley. Okay, this is a light. Light means what? Its mass will be negligible as compared to other masses. Okay, this is what our light smooth pulley. Smooth means what? Frictionless pulley. What is the meaning of word smooth? Smooth stand for frictionless. Okay, and here try to see the point here. Next point is what, guys? This is what? Okay, I will try to draw the smaller drawing of the pulley. So this is what our pulley. Okay, on one side what we have? On one side of the pulley what we have? 4 kg mass. Okay, this is what, suppose 4 kg mass. Okay, try to see the scenario. This is what, a 4 kg mass. Okay, this is a 4 kg. And on another side what we have? Guys, on another side what we have here? On another side what we have here? What is the other mass, guys? Can anyone tell me? What is the other 2 kg mass? Okay, so here we have a 2 kg mass. Okay, now what they are saying? The 4 kg mass is held 3 meter above the ground level with the tension in the cord and then released. So 4 kg mass is at what distance from a ground level? So this is what our ground. Okay, try to see the scenario. This is what a ground. This ground is visible to everyone. And this is what a ground. At what distance, guys, we have held? This distance is how much? How much they have mentioned in the question? How much that distance, guys? This 4 kg. Okay, how much distance? This distance is what? 3 meter. Okay, try to observe the things here. Now try to see the scenario. As this pulley is what, guys? What is the speciality of this pulley? What is the speciality of this pulley? This pulley is smooth pulley. So whenever we have a smooth pulley, what does it mean? Whenever we have a smooth pulley, what does it mean, guys? Tension on both sides will be same. Okay, so tension on this side. So 2 kg mass, tension on 2 kg side is what we will assume. This tension, as if you assume this as a F. Okay, if you assume this tension as F. Okay, try to see the point here. Then automatically this tension will also what, guys? What about this one? This will also what, guys? F. Okay, now what will be the weight of 4 kg mass? Weight will be what, guys? This weight will be what? 4g. What will be the weight of 2 kg mass? This weight will be what? 2g. Okay. Now, guys, see what they are saying in the question. Okay, try to see the scenario. The 4 kg mass is held 3 meter above the ground level. Okay, with the tension in the cord. There is a tension in the both cord and then released. What is meant by release, guys? What is the meaning of release? Initial velocity will become what, guys? 0 meter per second. What is the meaning of release? Release means what, guys? Initial velocity means what? this 4 kg mass is something on some platform. Okay, this 4 kg mass is on what? Some platform. And if you remove that platform, what will happen? This 4 kg mass will start moving downward. So how is the motion of this 4 kg mass? Motion of this 4 kg mass is what, guys? Downward. And in the direction of motion there will be acceleration. How is the for this 2 kg mass? Motion of the 2 kg mass is what, guys? Upward and along the direction of motion. Okay, guys, are you getting my point? Try to see the scenario here. Here motion downward and in the direction of motion we have an acceleration. Okay, guys, you got this drawing? Try to see the scenario. Try to observe this drawing, everyone. Okay, now what they are asking us in the A part. Okay, try to see the point here. What they are asking us in the A part. In A part they are asking us time taken for the 4 kg mass. Okay, what they are asking us in the A part? Time taken for the 4 kg mass to reach the ground level. Okay, what does it mean? It means time taken for the 4 kg mass to reach the what, guys? Ground level. Means to cover a distance what? How much distance? So here in A part, what they are asking us? They are asking us time. Time for what, guys? Time for what? To reach the what, guys? Ground level. Okay, try to see the scenario here. For 4 kg mass to reach the what, guys? Ground level. Okay, guys, are you getting my point? Try to see the scenario here. Okay, anyone have any doubt in this discussion? Okay, so here how much distance this 4 kg mass has to travel? How much distance 4 kg mass has to travel? 3 meters. So guys, now my question is, can we apply equation of motion in gravitational field in this scenario? Can we apply equation of motion in gravitational field in this scenario, guys? In case of this scenario, why we can't apply, guys? Yes, along with 4g, means along with weight, there is a tension is also acting. Along with 2g on this 2 kg mass, this tension is also there. Okay, guys, are you getting my point? Try to see the scenario here. Okay, very simple discussion, not that much difficult discussion. Okay, so here we can't apply equation of motion in gravitational field. Okay, so we have to use normal equation of motion. So here how much distance has to travel? That is the displacement here for this 4 kg mass. How much displacement is here? 3 meter. Okay, good. Displacement is what? 3 meter. Okay, try to see the scenario. Very simple discussion. Okay, now first of all, guys, so this is what our drawing, this is what our target, this is what initial velocity is what? 0 meter per second. Okay, try to see the scenario here. Instead of writing here, I will write down initial velocity is what? 0 meter per second. Okay, now first of all we will start our discussion with what? 4 kg mass. Okay, what we will start our discussion with what? 4 kg mass. Try to see the scenario for 4 kg mass. Very simple point, guys, not that much difficult. Okay, for 4 kg mass, what we are going to do? We are going to apply Newton's second law of motion. What is Newton's second law of motion? Summation of force is equal to what? Ma. Summation of force is equal to what, guys? Ma. So summation of F is equal to what? Ma. What are the forces here in direction of motion for the 4 kg mass? Direction of motion, which force is here? Direction of motion, guys, for this 4 kg mass. Okay, which one? 4g. And okay, only 4g is in the direction of motion, so we consider 4g as what? Positive. What about other force opposite to the motion? F. Okay, so F will be what, guys? Minus F. Mass is what? 4a. So F will be equal to what? 4g minus 4a. Try to see the scenario here. Okay, guys, any doubt in this discussion? Okay, now, so this is what? F is equal to what? 4g minus 4a, and we will say it as what? We will say it as equation 1. Okay, now then we are going to consider what we will consider? We are going to consider what? 2 kg mass. Okay, for 2 kg mass, try to observe these things. Everyone, don't write anything, don't do anything, just try to observe the things. Okay, what about 2 kg mass? Motion is how is the motion here? Upward or downward for 2 kg mass? For this 2 kg mass, how is the motion, guys? Upward or downward? Upward. Okay, motion is what? Upward. So forces in the direction of motion considered as positive, opposite forces negative. What are the forces here for the 2 kg mass in the direction of motion, guys? Only F, okay, tension F, okay. So F. Then what about other force, guys? F is in the direction of motion. This 2G is what? Opposite to the motion. So summation of F is equal to Newton's second law of motion first of all. Summation of F is equal to MA. So F minus 2G is equal to what, guys? 2A. So F will be equal to what? 2A plus 2G. And we are going to say it as equation 2. So if you observe this equation 1 and 2, guys, if you observe this equation 1 and 2, what is the speciality of these two equation, guys? What is the speciality of these two equation? Left hand side is same. If left hand side is same, then by default what will happen, guys? Right hand side will also same. So on equating equation 1 and 2, what we can write? 4G minus 4A is equal to 2A plus 2G. Everyone, are you getting my point? So what is the scenario here? 4G minus 2G is equal to 2A plus 4A. So what we can say? 2G is equal to 6A. So what will be the acceleration here? Guys, we are nearer to the answer. What will be the acceleration in this scenario? Acceleration will be equal to what, guys? 2, value of G is what? 9.81 divided by what? 6. So what will be the acceleration, guys? Please everyone do the calculation. So 2 into 9.81 divided by what? 6. How much, guys? 3.27 meter per second square. Okay, so we got acceleration. Okay. Guys, are you getting my point? Try to see the scenario here. So we got the acceleration and we know equation of motion. S is equal to what? Ut plus half at square. We know equation of motion is what? S is equal to what, guys? Ut plus half at square. How much is the displacement here? 3 meter. Okay, initial velocity will be what, guys? Initial velocity is 0. So half. A is what? 3.27. What we have to find out? Time. Okay. See the scenario. Huh? So we have to find out T. So T will be equal to what? 3 into 2 divided by what? 3.27 under root of this term. Okay. So please everyone do the calculation and tell me the value of time. Very simple discussion, guys, not that much difficult. So please everyone, under root of 3 into 2 divided by what? 3.27. Please let me know if I have done any mistake. How much time we required, guys? Any mistake I have done here? I think I have done some mistake here. How much, guys, answer we are getting? 1.35. What, guys? 1.3546 unit is what? Meter per second. Okay, cut. Sorry. Is it okay, guys? Oh, only second. So please be careful. Your teacher may do mistakes like this. So you have to be attentive in such type of scenario, guys. Okay. So try to see the scenario here. Okay. So in this way we got the what we got? Time. Okay. So first of all, guys, what you have to do? Try to draw this drawing properly. After completion of this drawing, write down the target. Okay. Then displacement, initial velocity. Then for 4 kg mass, leave the one line after equation 1. 2 kg mass, after that equating equation 1 and 2, our equation of motion. Okay. And then we will get our answer of A part. Okay. Everyone, any doubt in this discussion? Please write down properly, everyone. Now, guys, I am going to read the B part. Okay, try to read the B part carefully with me. The time the cord remains slack after 4 kg mass reaches the ground level if the 4 kg mass, try to see the scenario here. The time cord remains slack. Okay, what we have to find out? We have to calculate the time. Cord remains slack after 4 kg mass reaches the ground level if the 4 kg mass does not bounce back. Okay, try to say does not bounce. Okay, now what is meant by it? Okay, see when this, okay, I'm going to draw the another drawing here beside this drawing. Everyone try to see the scenario here. Don't draw anything, don't write anything. Okay, when this 4 kg mass, okay guys, try to see the scenario here. See, this is what our, okay, I'm going to draw a smaller drawing. Okay, we don't have to show here forces here, so I'm going to show. So this 4 kg mass, here on this side 2 kg mass. Okay, so after some time what will happen guys? This 4 kg mass what will do? Means after this time, okay, after 1.346 second, 3546 second, what will happen? This 4 kg mass what we will do? This 4 kg mass what we will do? This 4 kg mass what it will do guys? Touches the ground. Okay, when it touches the ground level, what about this 2 kg mass? What about this 2 kg mass guys? What about this 2 kg mass? Guys, I'm going to explain you, before explaining this question, I'm going to explain you a simple scenario that is happened with me. Okay, suppose suppose see, whenever I receive fees from any student, okay, try to see the scenario. Whenever I receive fees from any student, what I am going to do? I am trying to spend that fees as much as early as possible, because earning money is a difficult task, but spending we can do easily. Okay, so I can spend up to what time I can spend? Whenever I have that money, till that point I can spend that money. Okay, till that time I can spend, means whenever I have money, suppose I received some money from XYZ, suppose I received 250 USD from one student. Okay, and then what I am going to do? I am going to spend that money. Okay, whenever I have money, I am going to spend that money. Up to what point I can spend that money? Up to what point? Till I have the money. Okay, till the runs out. Okay, good. Till the money runs out. Okay, now see the point here. The same story is happen with this 2 kg mass also. When this 4 kg mass touches the ground, what about this 2 kg mass? When this 4 kg mass touches the ground, what about this 2 kg mass? 2 kg mass has also some velocity. See the scenario here. This 2 kg mass has some velocity. When this 4 kg mass, try to see the scenario here. Don't write anything, don't do anything. I am explaining you one important concept guys. Here, this question is combination of two things. One is our normal equation of motion, another is what? Equation of motion in gravitational field. Okay, so try to see the scenario. When this 4 kg mass touches the ground, so roll of 4 kg mass finished, because here in the question they said it does not bounce. Okay, means 4 kg mass will not go up. Now once this 4 kg mass get down, its roll get finished. But what about this 2 kg mass? When 4 kg mass touches the ground, what will happen guys? When this 4 kg mass touches the ground, what will happen? What will happen? This 2 kg mass has some velocity. Try to see the scenario. Okay, now guys, try to see the point here. Let V1 will be equal to velocity of 2 kg mass. Okay, velocity of what guys? V1 is equal to velocity of what? 2 kg mass. Okay, try to see the point. Velocity of, let V1 is equal to, save some space here. So let V1 is equal to what? Let V1 is equal to velocity of what? 2 kg mass when 4 kg mass touches the ground. Try to see the point here, everyone. Okay guys, are you getting my point? Everyone, what is meant by V1? V1 means what? Velocity of 2 kg mass when 4 kg mass what? Touches the ground. Okay, now how to get that velocity? See how story is going here. Try to observe both the drawings. Here I have drawn smaller drawing because here I don't have to show any forces, so that's why I have drawn. Okay, see, when 4 kg mass is going down, when this 4 kg mass going down, what about 2 kg mass? 2 kg mass is going up. When this 4 kg mass going down, 2 kg mass, when 4 kg mass going down, 2 kg mass is going what? 2 kg mass is going up. Okay, try to see the scenario. Huh? Everyone, screen is visible to everyone properly? Okay, so 2 kg mass is going up. Now, try to see the point here. So, when 2 kg mass is going up, at certain instant 4 kg mass will, what will do? What will do 4 kg mass? 4 kg mass touches the ground, but 2 kg mass will gain some velocity. This 2 kg mass will gain some velocity and it will come to this point. Okay, try to see the scenario. Okay, so till reaching this position of 2 kg mass, which motion it will follow? Means which acceleration it will follow? Acceleration A. Means see, acceleration of 4 kg mass and 2 kg mass is the same when 4 kg and 2 kg mass both are moving. Okay, here acceleration of both the masses is same when 4 kg mass and 2 kg mass is moving, till the velocity is what? Till the achieving velocity v1. Till the velocity v1. After achieving velocity v1, what will happen with the 4 kg mass? 4 kg mass touches the ground and v1 will get some velocity. So up to velocity v1, what will be the acceleration of 2 kg mass, guys? What will be the acceleration of 2 kg mass? Till the velocity v1, huh? Not I am talking about after v1. Till the velocity v1 means 2 kg mass, from this location 2 kg mass is starting from a rest. 0 to it coming from what, guys? It is going from 0 to v1. Okay, this 2 kg mass is going from what? 0 velocity to v1. Okay, and after v1 story is different. Okay, till 0 to v1, what is acceleration here? Guys, 0 meter per second to v1. What is the acceleration, guys? Acceleration for this one is what? Same, 3.27 meter per second square. Okay, I am talking about this scenario, guys. From 0 to, we are achieving up to v1, huh? Till reaching v1, up to v1 velocity. Now, guys, try to see the point here. So we know. So v is equal to what? U plus at. And how much time we have achieved this one? Guys, how much time we have achieved this velocity? So whatever the time we calculated in A part, in the same time we achieved this velocity. So how much time we calculated, guys, in A part? Can anyone tell me? 1.354 second. Okay. So how much time we have achieved the velocity for the 2 kg mass? V1 velocity. We don't know the value of v1. We are going to calculate the value of v1. We achieved that value in how much time? 1.3546 seconds. Guys, try to see the scenario here. Everyone. So we know equation of motion. V is equal to what? V is equal to what? U plus what? Everyone? U plus at. Okay. So we will say v1 is equal to initial velocity is what? Is starting from rest 0, 3.27. and 1.3546. Okay, so what is v1, guys? Everyone, what is the value of v1? What is the value of v1? So 3.27 multiplied by what? 1.3546. How much, guys? 4.443 unit meter per second. Okay, so we got the velocity v1. So till achieving this velocity, the 4 kg mass and 2 kg mass, this here both side have a tension. Okay. Now after achieving this velocity, guys, so we have achieved this velocity. After achieving this velocity, what will happen, guys? Once this 2 kg mass achieved this velocity, once this 2 kg mass achieved this velocity, what will happen, guys? What will happen? What will happen, guys? The scenario is what, guys? Try to see the scenario here. Means whenever someone has the velocity, what will happen? The velocity will not allow to keep it here only. This 2 kg mass will go up. Till what point it will go up, guys? Till its velocity will become 0. And when its velocity will become 0, then again it falls down. But during that motion, what will happen? Means after achieving this velocity, what is happening? 4 kg mass roll get finished. So there will be some velocity here. Okay, what is that velocity here? That velocity is what, guys? V1. This V1 velocity, what it will do? This V1 velocity, what it will do, guys? This V1 velocity, what it will do? It will not allow this 2 kg mass to keep at this position only. What it will do? It will try to move the 2 kg mass upward. Okay, and due to that, what will happen? This 2 kg mass will try to go upward till what point it will go, guys? Till its velocity will become 0. Try to see the scenario here. Okay, till what point this 2 kg mass will go? Till the velocity will become 0. And once its velocity will become 0, again it falls down. Now during that motion, after achieving velocity 0, till the velocity is 0 meter per second, and then again means how is it is going, guys? Try to see the point here. Very, very important discussion. Okay, how it is going, guys? It is going up. It is going up and then going down. It is going up. This 2 kg mass is going up and then going down. It is in same line, guys. Just for the reference, I am shown like this. It will not be like that. Okay, guys, are you getting my point? Try to see the scenario here, everyone. Everyone try to see the scenario here. Okay, so it is going up and then what? It is going up and then what, guys? It is going down. Okay, now what is the speciality of this scenario? From velocity v1 to 0 and again coming down. What is the speciality in this scenario, guys? During that motion from velocity v1 to achieving velocity 0, what is happening here? What is happened with this cable or this wire? What they have said in the question? Cable or wire, guys? Okay, what they said? Okay, cord they said. Okay, so cord. So what is the cord, guys? What is this cord? Cord, guys, see. Time the cord remains slack. What is the meaning of cord slack, guys? There will be no tension in the cord. And when there is no tension, because why there is no tension? Here, there is not any force on this side or there is not any mass on the other side which is pulling this here. Okay, so what is the scenario here? When this 2 kg mass achieved the velocity, v1, what will happen? What will happen, guys? The tension in the cord will become what, guys? This tension in the cord will become 0 and tension in the cord becomes 0 means what? The cord will become slack. Guys, there is a word in the question. Okay, what is that word? What they have to find out in the question? The time the cord remains slack. Okay, so time of slack we have to find out in the B part. Okay, try to see the scenario here. So in B part we have to find out time of slack. Okay, time of slack means what? What is the meaning of word slack? Slack means what? What is the meaning of word slack? Slack means what? No tension. Okay, and why it is no tension in the cord? Because this 4 kg mass will not have. See, in A part, while dealing with A part, see, as 2 kg mass moves upward, 4 kg mass moves downward. So there we have a tension in the cord here. But once we achieve this velocity v1, after achieving velocity v1, what has happened? This 4 kg mass touches the ground. As this 4 kg mass touches the ground, so this 4 kg mass will not create any tension in the cord. And if there is no tension in the cord, there is velocity in this 2 kg mass. What will happen? This velocity will try to move that object upward. Okay, without any tension. And without any tension means what? No slack. Means without any tension means what? No slack means that is not there will be slack. Okay, got it? Means our cord will become, what is meant by slack? Our cord will become loose. Okay, what will happen with our cord? Cord will become loose. Okay, guys. And when there is cord, it will become loose. So there is no tension in the cord. So on this 2 kg mass, which force will act after reaching this 4 kg mass to the ground? Guys, I am explaining you once again. Only gravitational force, and whenever only gravitational force acts on the object, guys, whenever gravitational force acts on the object, okay, what will happen? What will happen? What will happen, guys? Okay, so we can apply equation of motion in gravitational field. So guys, so during slack period, okay, try to see the scenario here. Now you got up to reaching v1, we have acceleration 3.27. Up to achieving V1, we have acceleration 3.27. But after achieving V1, what will be the scenario? We have to follow equation. So there is only gravitational force, no tension on the here. So guys, so now try to see the scenario here during slack period. The next point is what, guys? During slack period. Now the next point is here. Object is going up. This 2 kg mass is going up and it is going down. So what is its displacement? Means it is going up and again coming back. What is its displacement, guys? 0. So during displacement, what is its displacement, guys? 0 meter. Why 0 meter, guys? It is going up till the velocity will become 0. Okay. And after achieving 0 meter per second, again it is coming back. Okay. Everyone getting my point? Okay. So try to see the scenario here. So 0 meter. Our initial velocity in this scenario will be what? During slack period is our V1. Initial velocity is what? Our V1. 4.43 meter per second. Try to see the scenario here. Okay guys, are you getting my point? So we can apply equation of motion y is equal to ut minus half gt square. Here we have not applied, guys. See, there is a two scenario. One scenario, our 2 kg mass starting from a rest, achieving a velocity v1. From 0 to v1, acceleration is a. Then in second scenario, it is going up. Guys, try to see the scenario. In second scenario, it is going up and again coming back to this one. Means, see guys, are you getting my point? Try to see the point here. So in second scenario, v1 0 and again v1. Okay, so v1 to 0 and 0 to v1 means that maximum height. So this period is what, guys? What is this period? This period is what? Slack period. Okay, and why slack period? What is the meaning of slack period? In that period, when v1 to 0 and 0 to v1, there will be no tension in the cord, and if there is no tension on the cord, only gravitational force will act on the object, on this 2 kg mass, and if there is only gravitational force act on this 2 kg mass, what is happening? So what we can apply? We can apply only equation of motion in gravitational field. We can apply easily here. Okay guys, are you getting my point? And why y equal to 0 here? Because means it is starting, come back to its, see that position, original position, that to here, means from v1 to going to 0 meter per second and again coming back to its original position. So its displacement is what? 0. And here it is starting with a velocity of what? Slack period. Slack period is starting with which velocity? It's starting with the velocity of v1. Okay, so v1 will become initial velocity for the slack period. Okay guys, are you getting my point? Try to see the scenario here. So y is equal to what, guys? 0. U is what? Initial velocity is what? 4.43 into t minus half into 9.81 into t square. Guys, try to observe the scenario. Very simple discussion. So 0, 4.43. Okay, let me know if I have done any mistake. Minus 4.908 or 905. So 905 t square. So 4.905 t square, 4.43. We can cancel 1 t. So here we can cancel. So only 1 t will remain here. So what will happen, guys, here? So try to see the observe, guys. Try to observe the points here. So 4.905 t is equal to 4.43. So time of slack will be what? 4.43 divided by 4.905. Everyone do the calculation and tell me the value of t. Everyone. Very simple discussion, guys. .43 divided by 4.905. How much, guys? Value we are getting? 0.9032 second. Okay, so this time will be what? Our time of slack. You got the meaning of time of slack, guys? Anyone have any doubt in this discussion? Guys, just before writing anything, take a 1 or 2 minutes, guys. Just observe the scenario here. Just observe, guys, everything. Means our A part drawing, Then we have started B part from here. Then we achieved velocity v1. After achieving velocity v1, 4 kg mass is touching the ground. When 4 kg mass touches the ground, there is no role of 4 kg mass. 4 kg mass will not able to pull the cord. Okay, if 4 kg mass will not able to pull the cord, then there is no tension. Okay, and this 2 kg mass has some velocity. This velocity will not able to keep it in at rest. Okay, what is that velocity will do? Try to move this 2 kg mass upward. When this 2 kg mass try to move upward, it will go up to velocity will become 0. After achieving velocity 0, then again it is coming back. During that entire period from v1 to 0 and again 0 to v1, what is happening? There is no tension in the cord, means slack. And what is the meaning of slack? Slack means no tension. Our cord will become loose. Okay, guys, are you getting my point? And why cord is loose? Because 4 kg mass is touches the ground here. Now then we have calculated velocity v1, and till achieving v1 we have acceleration 3.27 meter per second. Guys, observe the things. Okay, so here till achieving v1 we have acceleration 3.27 meter per second. In how much time we have achieved this 3.27? Sorry, in how much time we have achieved the velocity v1? We have achieved the velocity 1.3546 in second. That is our answer of A part. Okay, this is what our answer of A part. Okay, in this much time we have achieved velocity by using this much acceleration. Okay, then we calculate the v1. So we have a velocity of this 2 kg mass. With this velocity, slack period start. Okay, and slack period will up to this time. Okay, during slack period, what is the speciality of slack period? During slack period, only which force is acting on this 2 kg mass? Only gravitational force is acting on the 2 kg mass. So due to that gravitational force, we can apply equation of motion in gravitational field, and our slack period starts with a velocity of 4.43 meter per second. Okay guys, any doubt in this discussion? So guys, don't draw this drawing. This drawing is not for us. We have already drawn this drawing in the A part. So guys, give the target of the B part. We have to find out the time of slack. Then draw this drawing. Write down the meaning of slack. Slack means no tension in the cord. Then write down this scenario. After that, guys, write down this point. Okay, please everyone try to write down properly, guys. Means in any technical subject, whether it is a EKS or heat or mechanics or any subject, in any technical subject, the most important thing is revision. And for revision, you should have a proper notes. Because if you studied these subjects for 2 months and if you are not done proper revision, then it is difficult to pass any subject, guys. So always, and for revision, you should have a proper notes. Okay, so please try to take the notes always properly. Everyone, please write down properly.